Okay, students, this should be a little shorter video than what maybe you've been seeing. I wanted to start off with what we had written down in class, that a tangent line is a straight line that touches a single point on a curve to show the steepness or the slope at that point. So here's what we're going to be doing. What I would like to do, and what you're supposed to be doing for this assignment, is to describe the slopes in each of these graphs. So we have 5 different graphs here, and I want to be able to describe the slope itself. So if we look at the first one here, this looks like the same kind of graph we've been having, like the tumble buggy constant velocity motion here is what we're looking at. So how are we going to describe that slope? Well, it looks like it's positive because it's sloped upward, and it's constant, meaning the slope's not changing. It has a steady steepness the whole way. All right. Now, what I want you to remember here is that the same words we're using to describe the slope are also describing the velocity. So, again, we're talking about a positive constant slope, which means a positive constant velocity. Because remember, that's what the slope of the xt graph is. It is the delta x, or the change in position, over the change in time. That's what we're dealing with. So on to the next one. For the next one, though, we're going to need some tangent lines. Now again, this is the kind you just saw in the go-car lab. So let me see if I can actually draw some tangent lines on here. I don't know if it's going to work or not. But, oh, that's not good. Let's try that again. Maybe right about here. That's not too terrible. And then maybe right about, oh, that's bad. Yeah, I was afraid of this. Whoa, that's the pointer, not my dang pen. Alright, here we go. Oh my gosh. I'm having as bad a time as I did in class. Okay, I guess that's decent. And that's at the beginning. And then the slope over here, oh, that's not too bad. So, here's the deal. Early on, the slope is not very steep. Later, the slope is much steeper. So how are we going to describe the slope? I would describe it as, first of all, positive, because again, it's tipped up, right? The tip up here means it is a positive slope. So again, we're going to say it's positive. Now, is it constant? No. Well, what is it then? We would say increasing. The slope is getting steeper, you see. It's increasing. Now, that means we're talking about the slope, okay, or the velocity. So that curve is telling us that we are having an increasing positive velocity because the tangents to the curve are getting steeper. I hope you're following along with that. All right, next one. Let's see here. A slope or a tangent at the beginning might look, oh, I tell you, I'm struggling. Trying to use a straight edge on an iPad, it is not easy. Oh, that's pretty good. That's the best I've seen. All right, let's see. Not quite, almost. Oh, that's not bad. So, what are we looking at here? Well, the first one I drew, the one closer to time 0, that's pretty steep. This one here, it's not as steep. So what's happening to the slope? Well, first of all, what kind of slope is it? Is it still positive? Yes, it's tipped up. So we're still talking about a positive slope. What is it doing? Is it increasing? No, it's decreasing. It's getting less steep. So it is a decreasing slope. Now again, we're talking about slope, but really we're talking about, remember, velocity. So this graph is actually showing a positive but decreasing velocity because it was steep at the beginning and it's getting less steep as time goes on. So this one started off not very steep and got steeper. This one started off steep and then started getting less steep. So decreasing, positive velocity. All right, next. Okay, let's see. How are we going to draw this? Let's see. Oh, that's pretty good. I got to tell you, that's pretty. Oh my gosh, that's terrible. Oh no. Oh man, I can't do. Oh, that's a shame. I can't just get rid of one of them? Oh man. That's terrible. There's nothing I can do about that. Well, I'm going to have to try this one again. The laser. Oh my gosh. I swear. Okay, that's going to be okay. And I got to get another one. Oh, jeez. Let's try that again. That's pretty good. So, if you look at this one, early on, I wonder if I can move that. Whoa, not the whole thing. Forget that. So, the first line, that's pretty steep. This one is less steep. So the first one, closer to the 0 time here. Again, that's early on in the curve. That's steep, getting less steep. Now, how is it tipped though? It's tipped down this time. It's tipped down. These are tipped up, that's positive. These are tipped down, that's negative. So we're talking about a negative, and is the slope getting steeper or less steep? It's getting less steep. So we're talking decreasing. And again, we're talking about the slope. But hopefully you realize by now we're also talking about the velocity. So this curve is telling us that the velocity is starting off pretty large and negative because it's a negative slope, and it's getting smaller, meaning it's getting less steep, and therefore the velocity is decreasing. So this is a negative and decreasing velocity because the slope is negative and decreasing. All right, last one. Oh, let's see. At the beginning of the time interval, oh, that's terrible. It is, that's pretty good. Oh, maybe something I should do here. So this first one over here looks like it's touching at about that point. This one looks like it's touching at about this point. So these are the places that these tangent lines are touching the curve. So it's touching the curve here, and it's touching the curve over here. So I'm showing you this is early on. This is early on. It's very horizontal. Now, as we go further, let's get the blue pen back. As time goes on, it looks like the slope is getting, oh man, not quite where I need to be. Whoa, I don't know what just happened there. I guess that's gonna have to be good enough because I'm not going to try it again. So that's touching at that point. So notice, what kind of slope did we have at the beginning? That's horizontal. That would be called a zero slope. And what's happening to the slope as time goes on? Well, that's steeper, right? But it's also tipped down. Steeper and tipped down, we're talking negative here. These slopes are negative on this curve. Negative slope. And is it getting steeper or less steep? Remember, it's starting off with no slope and getting steeper. So that means it's increasing. So we're talking about a negative increasing. Oh boy, running out of room on the screen. So negative and increasing slope, which again, that means we're talking about velocity. So I hope you're able to see and look at what the tangents to the curve are doing. Starting small, getting steep, that's increasing. Starting steep, getting smaller, that's decreasing. Starting steep, getting smaller, decreasing. Starting with no slope and getting steeper, that's increasing. And you have to know whether it's negative or positive based on which way it's tipped. So I hope that helps with how to interpret what's happening to the velocity in a position time graph using tangent lines on the curves. Hope that helped. Okay, everybody. Whew. All right, that first part was filmed or recorded. I guess it wasn't filmed. Oh my gosh, my chair's making all kinds of mess. That first part was recorded. I don't know when it was. It may have been a while back. So this is me literally sitting in my chair. Oh, what time is it? It is about 4:52 exactly on Thursday afternoon/evening. So I'm adding now to the previous recording. Now, if you'll notice, I have on my little screen here what I was telling you the other day in class is that you have motion maps above, and then we have VT graphs below. So what do those look like now that we finally have gone through each of the graphs to talk about whether the slopes are positive, negative, or whether they're constant, increasing, or decreasing? So now that we have all that figured out, let's talk about what this actually means in terms of graph number 1 and positive and constant. Again, we've seen this a bazillion and a half times. This is the tumble buggy situation, and so we are showing a positive constant velocity, which means our arrows have to be positive direction and constant length. Oh! Now, where does it start? Where does the object start? It starts at the origin. So my first dot has to be at the origin. Okay. So now I got to get my pen back out. Let's see. I got to get my pen. Let's go with red ink. There we go. That's good. Yeah, red. And so my first dot here, I hope, and then arrow, and then arrow, and then arrow. Now, I hope those are all about the same length. They should be, because it's positive and constant. Now, next graph, it says positive increasing slope, which means velocity. Positive increasing velocity. So now I have a positive velocity, and it's increasing, which means my arrows have to get longer. Yes. I hope you were thinking longer. Now, the question, where does the object start in this graph, or in this motion map? Well, where does the line start in the graph? It starts at the origin or zero position. Actually, just above it, but it's okay. It's supposed to be at the origin. So I get my pen back, and I draw my first arrow. Oh, gosh, get off of there. First arrow right there, and it's very short because my arrows have to get longer, and that's a little longer. And then I draw my next arrow even longer still. There you go. There's your motion map showing a positive and increasing velocity where the object starts at the origin. Next graph, we have a positive decreasing slope or positive decreasing velocity. So how do I show a velocity? Oh, I probably should have done the VTs right after the, oh gosh, okay. I'm going to go back. Okay, oh boy, no. Okay, so this one, how do you show a positive constant velocity on the VT graph? If you don't know this by now, then I don't know what to tell you, because we've done this a lot. And so positive constant looks like that, well, sort of like that. It's supposed to be straight across. I had a little wiggle. So that shows positive and constant velocity. Now the next one is supposed to show a positive but increasing velocity, which again we just saw yesterday in class. Unless you weren't there, then you didn't see it. So positive and increasing would be that. The values are getting bigger, and it starts, oh, that line is not exactly in the right place. I bet you I can't move it. Can I move? No, I can't. Oh, man. So, oh, jeez. I wonder if I can't do that either. Oh, this is terrible. All right. So that's supposed to be at the origin, 0 velocity, because looks like I have about 0 slope at the beginning, no slope, and then it's big and positive. So I have no velocity here, and then I have big positive velocity at the end. Okay, moving on. This one, positive decreasing. So now my velocity is positive at the beginning, but it's also getting less. It's decreasing. So how do you show a positive velocity that's getting smaller? Where are positive velocities? Up here. How do you show it's getting less? Like that. So let me get my pen. Oh my gosh, this thing is so messed up. Right like that. Boom. And the next one. So now we have a negative decreasing. So it's negative and it's getting less. Negative and getting less velocity. Where is negative on this? If that's 0, those are positive, negatives down here. So it's negative, but it's actually getting less. Well, how do you mean less? Well, I mean closer to what? The 0. So if I put, maybe I should have put these on there. I should have gone, that's the 0, those are pluses, those are minuses. So if it's be negative and decreasing, it starts in the negative velocity and it's getting less and less, closer to 0 velocity. That would be negative and decreasing, which doesn't make much sense because the line's going up, and then you automatically think most of the time if it's going up, then that means it must be getting bigger. Well, no, it's getting closer to 0 velocity from a, oh, I didn't even do the motion maps yet. Oh my gosh! Why didn't somebody stop me? Okay. I did these two to catch up with this. And then I just kept on blowing right through, forgetting that I hadn't already done these yet. Okay. Back to the motion map. How do I show a positive? Oh, that's not, oh my gosh. How do I show a positive decreasing velocity? Well, the arrows have to point positive, and they have to get what? Shorter. So that means I got to start with a long arrow because it was fast at the beginning. Whoa, that's probably too long. And then it got shorter as it went. So like so. How about like that? There you go. That's positive and decreasing. Now the next one. Now also notice something else. This graph, the object started at the origin, motion map started at the origin. This one, object started at the origin, object started at the origin. This one, object started at the origin, object started at the origin. This one, does the object start at the origin? No. It starts with a large positive position. Large positive position, traveling in a negative direction, and getting slower. Decreasing slope means decreasing velocity. That's getting slower. Negative direction, getting slower. So what does that mean? Negative direction, getting slower, starting with a large positive position. Starting out here and traveling in a negative direction and slowing down, which means it has to be fast at first. Fast at first, and then getting slower as we go, like so. And then maybe, well, I guess it doesn't look like it stops, so I'll just leave it as an arrow and not a dot. So that would be negative velocity, but decreasing or slowing down. Okay, and that's what we see on the velocity time graph. And now finally we're on the last one. And so we see that, again, this one does not start at the origin either. This one didn't, and this one didn't. So that means my first dot and arrow are going to have to be like out here somewhere. Positive position. What is happening to the slope? It's a negative, and it's increasing. In other words, it's getting steeper. It started with no slope. Now it has a large negative slope. So it's starting with no velocity and then getting faster negatively. What does that look like? Hopefully you drew something like this. Short at first because it's not very fast, but it's getting faster the closer it gets to the origin. And boy, those arrows are wonky. All right, now that we have that, now we got to talk about this right here. Negative increasing. How do you show negative increasing here? It's negative, but it's getting bigger, getting faster. How much velocity did it start with? That's like asking what the slope is at the beginning. 0. It had 0 slope. Oh gosh. There. It had 0 slope at the beginning. And what happened to it? It got faster, but it got faster negatively. That's down this way. So I hope that you're able to follow along with that and make sense of it and figure that out. Okay. So that should do it for the top part. Now for homework, or classwork, you will do the rest of the worksheet, which has a graph with some data on there, and then you will be able to plot the data points, find or draw best fit, find the slope of the line, and write out an equation. Now I will remind you, I hope, let's see, you know what, maybe I can get a new slide here. Hold on, just a second. Oh boy, no, I don't need a new slide. I'll just use this. When you have a velocity time graph and you have a line on it that has a slope, you can write an equation for that line just like we did for the position time graphs, only it will be a velocity time graph. So instead of position as your y variable, you now have velocity. You still have time as your x variable, and of course you have a slope and you have a y-intercept, and so all those things can still be done. So you'll have to do that and then answer the questions that go along with that for the data set there for part B of the worksheet. So good luck with that. Hopefully you won't have any questions and it'll go splendidly and you'll get it all done before you leave. And I apologize for the length of this video. But hey, I mean, it is what it is. You can't be perfect at everything. So have yourselves a wonderful weekend, and I will see you on Monday if you're lucky. Bye.